Good evening. I'm looking at the question. It's on the handout. Please report that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% are given a blood test, and 22% are given both tests. What's the probability that a randomly selected DWI suspect is given a test? That'll be our first question. We'll work on the other two in a minute. But when I'm given something like this, I usually start by drawing a Venn diagram. I don't see any conditions. I don't see any of that other stuff. So I'm going to start with my Venn diagram. I'm actually going to start by labeling my events A or B. How about A will be they get a breath test, and B, they get a blood test. Usually way more expensive. So I've got a nice big circle for A, nice big circle for B. Now, I know that, and I'll call this side A and this side B. The overlap is the people that had both tests. So I'm going to put 0.22 in there. 22% had both. Out inside of A, everything inside the circle of A is 78%. If I had 100 drivers, 78 of them would, if I had stopped drivers, 78 of them would get a breath test, but 22 of them are given the blood test also. That leaves behind 56 or 0.56 that didn't get both. Okay, the 0.22 and the 0.56 add up to my 78%. And by the same token for B, with a blood test, I had 36% altogether got a blood test. But of that 36, 22% got both. That leaves behind only 14% that didn't get both. But when I add the 0.22 to the 0.14, I get the 36% that had the blood test. So the first question is, what's the probability of getting a test? That's the probability of A or B. That's everything inside of those circles. That's everybody that got a test. So that would be 0.56 plus 0.22 plus 0.14. I know I hate not having those zeros. And that will all add up to 0.92. Okay. Now you might think you're done, but in fact, I want these to be put in context. So you would say the probability of getting a test a driver stopped on suspicion of getting a test. I'm running out of room. Is 92%. Okay, with a period. All right, so then I want to look at the next one. That's the probability they get a blood test or a breath test, but not both. And this is the kind of problem that for me a Venn diagram is beautifully visible, because I can see right on there which ones got a blood test or a breath test, but not both. And that's the people that are in A or B, but not in the overlap. Okay, that's going to be the whole thing, the 0.92 minus the overlap, and that leaves 0.70. And in context, the probability, and I'm going to shorten it, but you can't, of a randomly selected DWI suspect is given a blood test or a breath test, but not both, is 70%. Yeah, I'll bet you shorten it. But just remember, I'm looking for that full answer in context on quizzes and tests. So then the last one is the probability that a randomly selected suspect is given neither test. And that would be everybody that's outside of my circles. It's the complement of everything that's in. So probability of getting neither test is the complement of getting a test at all. Okay? So that would be equal to 1 minus 0.92. And that equals 0.08. So the probability of getting neither test is 8%. All right. Now, it can be helpful sometimes to put them in a table. Some people see this in tables better. My table got squished a little, but I did breath, no breath, and total, blood, no blood test, and total, like that. And I'm told that the percent that get a blood and a breath, and that would be right here where these two meet, is 0.22. I know the total is going to be 1. And the ones that get the total number of ones that get a breath test is 0.78, and the total that get a blood test are 0.36. Okay. Now, with what I've got, I can fill in the rest of the table. I know that blood and no blood add up to 0.36, so I subtract that, I get 0.14. I know that 0.78 is the sum of this 0.22 plus whatever is no. When I subtract, I get 0.56. I know that 0.36, the total adds up to 1, so I can fill in the no column, the no row. That's going to be 0.64. This is going to be 0.22, and that means this has to be 0.08. It works from both directions. So that can be really helpful too, to use a table. Probability that they don't get both, that they get neither, it was 0.08, and that's right here. The probability of that they get a test at all, 0.92. It's not obvious on here. So for me, the Venn diagram with this kind of problem is just easier. Here they are together. Sometimes you got to try both. Yep, I got my table right. Yay. The question, though, is what's the probability that someone who's had a breath test gets a blood test? And for me, in that kind of question, conditional probability, the table is much easier. So I'm interested in someone who's had a breath test. You know they've had a breath test. People who've had a breath test are yes to the breath test. That's this whole column. Okay? That's 0.78. So I'm interested in the probability that someone, I know they got the blood test, that's A. What's the chance they got the breath? That's B. Well, I know that 0.78 of them get the breath test. And out of that, I want to know the probability that they have the blood. That's 0.22. And when I do that on my calculator, 0.22 divided by 0.78, I get 0.2821. And I really like probabilities to go to 4 decimal places. So in context, probability, so probability, someone who's had a breath test gets that blood test is 28.21%. That's pretty good. Now I've got a flying question. Leah is flying from Boston to Denver with a connection in Chicago. The probability that her first flight leaves on time is 15%. If the flight's on time, probability her luggage will make the connecting flight in Chicago is 0.95. But if the first flight is delayed, the probability the luggage will make it is only 0.65. what's the probability that her luggage arrives in Denver with her? With this kind of complicated question, I set up a table right away. And you can see what I've set up. The first row is the first flight is on time, the first flight is delayed, and then the total. My rows are going to be the luggage is on time, the luggage is delayed, and the total. Now, the first part is probability her first flight leaves on time is 0.15. That's a total. So that goes here. If the flight is on time, so it would be easier, wouldn't it, to use 100 people. I'm going to do that. So out of 100 flights, 15 of them, the first flight will be on time. That's what we expect. Now, the next part says, if it's on time, so out of those 15, the probability that they make the connecting flight is 0.95. So when it's on time, that the luggage is on time, 95% of it will do that. So that would be almost all of it. It's 14.25%. Now, I know that if the luggage is delayed, it's going to add up to the 15. That'll be 0.75 out of 100. The next thing, if the first flight is delayed, the probability that the luggage will make it is only 6.5. So if the first flight is delayed, now, I know over here is 100, so I know that the first flight is delayed has to add up to 100 with the 15, so I know that's got to be 85. If the first flight is delayed, the probability that we'll only make it is 0.65.